Welcome to Brain Vision.
16.24. So we have this set up with a couple of strings and some pulleys and a mass that they're supporting. So first we want to find what the wave speed in string 1 and string 2 is. And then we imagine setting up this other situation where string 1 and 2 are the same material as before, but now this mass has been broken up into two pieces. And so we want to find these two masses such that the wave speeds are equal on each string. So from the hint in the problem where it says when a string loops halfway around a pulley, it pulls on the pulley with a net force that is twice the tension in the string. This implies that the tension in either string is going to be the weight of the mass divided by 2. So the speed in string 1 is going to be the tension divided by mu1. So that will be 28.6 meters per second. These are all given in grams, so just remember to convert those to kilograms if you want to come up with a number that means anything in SI units. So similarly for string 2, it's going to be the tension, which is the same in both, divided by its respective density. And so its wave speed is 22.1 meters per second. Now for C and D, which I mean we might as well just consider together, we're going to have the same sort of story here. V1 is going to be the tension, which will now have the tension in string 1, which is going to be m1g over 2 divided by mu1. And with the necessary things being changed, it's the same over for string 2. So m1 plus m2, like we said here, has to equal the big M. So setting these equal to each other, we can solve for m1 and we end up finding that this is m, the total mass, divided by 1 plus the ratio of the two densities, mu2 over mu1. So m1 has to be 188 grams. And then, since we know the total has to be 500, we can just subtract this from 500, and we get 312 grams.